Project title is Improving the Efficiency of Horizontal Axis Wind Turbine by Using Counter-Rotating Rotors. The abstract. Present work was investigated to increase the performance of the horizontal axis wind turbine. It consists of two turbine rotors consisting 3 blades each. Size of the first rotor is smaller than the second rotor. Both rotors are connected to the double feed induction generator through different shaft arrangement. The performance of the single rotor is less, so the aim of the work is to improve the efficiency of the wind turbine more than betz limit by using two rotors. The blade profile chosen for analysis is NACA 4412. The model was created using CATI and analysis were done using ANSYS FLUENT software, and structural analysis was also done in Cosmos 15.0 for the material aluminium to improve the strength of the wind turbine blade. Literature review. The literature paper used for doing literature review was the following. Induction. Wind turbine is a device used for converting the kinetic energy of the wind into electrical energy by using the power of the wind. The correct description for this type of machine would be aerofoil generator. Wind turbine used for charging batteries may be referred as a wind charger. Horizontal axis picture of horizontal axis wind turbine. Betz limit. Betz limit shows the hypothetical wind energy extraction machine. The fundamental laws of conservation mass energy allow not more than 59.3% of the kinetic energy of the wind to be captured. It can be approached by modern turbine designs, which may be reached up to 70 to 80% of the theoretical limit. Testing software. CATIA is the software used for modeling, and it is a multi-platform CAD/CAM CAE commercial software suite developed by French company Dassault Systems. ANSYS FLUENT software contains a broad physical modeling capabilities needed to model flow, turbulence, heat transfer, and reactions for industrial applications. Cosmos Works is a design, analysis, automation application fully integrated with SolidWorks. It uses FEM to simulate the working conditions of your designs and predict their behavior. The solution of large systems of equations powered by fast solvers. Cosmos Works makes it possible for designers to quickly check the integrity of their designs and search for the optimum solutions. NACA airfoil 4412 is used as a designing airfoil. The chord line is a line which passes through the upper and lower part of the airfoil cross section. Leading edge is the front part of the airfoil, and trailing edge is the rear part of the airfoil. There are two forces acting on the airfoil, cross section of the airfoil, when wind passes through it: lift force and drag force. Lift force is the perpendicular force acting to the direction of the motion of the blade, and drag force is the parallel force acting to the direction of the motion of the blade. Methodology. Modeling and analysis were done using the CATI and ANSYS software. Flow analysis were carried out to find out the lift and drag values. It is used to find out the increase in the performance of the dual rotor wind turbine. Specifications considered are density, velocity, number of blades, blade length, swept area, cut-in speed, cut-out speed, rotor dia of the first rotor and second rotor, tip speed ratio, angle of incidence, and rotational speed. Working diagram of counter rotating rotor wind turbine. And it consists of two rotors. One rotor, second rotor is sizes larger than the first rotor, and both are connected to the generator using different shaft arrangement, and gear drive system is used for transmitting the power to the generator. This is a CATIA model developed for single rotor arrangement using the CATIA software. This is a CATIA model for two rotor arrangement, which consists of two rotors. This is a model imported to the ANSYS software. This is single rotor arrangement for single rotor arrangement. This is for double rotor arrangement, the model which is imported to the ANSYS software. This is a final converged solution, single rotor setup solutions, scale residuals for which is obtained in ANSYS FLUENT software, and this is a graph obtained for coefficient of lift, which is around 1.25 10 to the power minus 2, and this is a value graphs obtained for coefficient of drag, which is around 4.767 e per minus 4, and this is a solution obtained for double rotor setup scale residuals plot using ANSYS FLUENT software. This is analysis results for coefficient of lift for second rotor, which is around CL value is around 2.26 into 10 power minus 2, and this is a plot obtained for coefficient of drag. The value is around 4.70 e power minus 4, and the calculations power off is equal to off into rho A V cube, and obtained available power is 790.85 kilowatts, and torque calculations are done, and finally the values is 3.62 kilonewton per meter. Output power is torque into rotational speed, torque into angular velocity. The value obtained is 360.26 kilowatts. Efficiency is around 45.32. This is for single rotor arrangement. For double rotor arrangement, the available power is around 1700 kilowatts. Torque calculation, we have obtained the value is 10.798 kilonewton per meter. The output power is 1007.98 kilowatt. Efficiency is around 60.34, which is quite higher than that of the single rotor arrangement. The comparison using graphs, we have plotted the front set rotor, which is giving efficiency around 45%, which is lesser than that of the betz limit, which is around 59.3. The second plot, which shows the comparison between front set of rotors, that is single rotor system, betz limit, and also both counter rotors. In this efficiency of the counter rotor system which we designed is above 60, which is more than that of the betz limit. This is Cosmos analysis, the flow diagram. First the model is created, and structural linear velocity is given. Material we used is aluminum Al1060H14, and the next step is contact is fixed, and input is given, meshing is done, and finally the result is obtained using the model imported to the CATI and model imported to the CATI V5. Blade structural analysis, which was done using Cosmos 15.0. The green part of the model shows that the design is safe, so it may not undergo any fatigue stress or something. This is single rotor arrangement analysis, which is done using Cosmos 15.0. Here also you can see around the blades, at the edges of the blades, green color indicates that again the design is safe and no stress or strain is maybe occurred on the blade surfaces. And this is double rotor analysis setup. Here it is shown the various load factors which is acting on the surface of the double rotor arrangement, and here also design is considered as safe. Conclusion: finally, the design counter rotor horizontal axis wind turbine was analyzed in ANSYS workbench 13 FLUENT that obtained the results and plots as per analysis. The wind turbine increased efficiency when the two rotors rotates as a single unit, and the power coefficient rate increased from around 44% to 60.3% comparing with the betz limit. It is quite higher. Thank you.